Hello, good afternoon. Um, the the device that will be um, under inspection today is something pretty common, uh, something that converts analog data to digital data, and something that we use very often in today's day and age. So this thermometer is pretty standard. Um, Turn it on. Uh, Takes your, data from your hand, like a heat signal, and reports it as a digital signal on the screen. And I will try to reverse engineer and figure out how um, this thing works.
So this is the deconstructed thermometer. I can break it down into its different parts. So this is just the main body of the thermometer. This is the button cover. So this small rubber piece fits under this power strip like that, and then that all connects to this small gold circle right here, which is like where the button interacts with the circuit. So this is to power on the system. This is the main cap that kind of houses the battery of the circuit, and this battery is what drives the current through the circuit and allows the current to move from a low potential to a high potential. So that's what powers this entire system. This is kind of, these small metal pieces are kind of what hold the battery in place, and they are made out of conductive material of metal, which allows the current to travel from the battery throughout the rest of the circuit. So then this right here, these small copper wires are where the heat signal, your analog signal from the probe, comes from into the circuit. So it travels kind of from this area into the circuit, which allows it to be processed into digital data. And this small gold strip here is what kind of vibrates when a signal has been processed. Then to the actual circuit itself, you have a small black strip. This big blob here is kind of what houses the protective layer over the main processing chip of the circuit, and that's kind of like the whole brain of the circuit, how it operates, and what it basically allows it to do its main function of converting data into something readable. The small blue strip is a resistor. More specifically, it's like a thermocoupler, which is kind of like a sensor for reading thermal data that's gathered from the probe. And then when it reads this data, allows for a small voltage to be kind of created, and then the rest of the circuit, like all these small units here, are all kind of devoted to converting the signal. First of all, being able to amplify it, and then converting it from analog to digital, and finally allowing it to be displayed on the screen of the circuit. So these strips here kind of allow different numbers, letters to be displayed on the screen, kind of like this. And the screen's kind of cracked because of the spill of liquid inside, but this is called like a LCD or a liquid crystal display. And then finally, this rubber strip here is called a zebra strip. It's kind of elastic, and there are regions of it which are pretty conductive and other regions which are more insulated. So basically the main function of this is just to allow for um, the connection to the screen, um, to the rest of the circuit, um, and then just make sure that the screen is actually receiving connection. Looking at anything else on this thing, pretty much that's everything of my knowledge. So yeah.
And the main reason why um, analog is not preferred to digital for these types of machines is because digital has much less noise signals to it, so it's easier to read. And analog is kind of more of that raw data, which is heat, light, sound. So being able to convert it to something digital can be read easier, and it's just more compatible with computers and other electronic things. So, yeah.